Hello, my name is Ashish Udgave. I am working as Assistant Professor in Department of Mechanical Engineering, Sharad Institute of Technology, College of Engineering, Yatrav, Itsalganji. I am welcome to all in the lecture of Basic Concepts, Module number 1. In last video, we have covered the concept of basic terms like moment of force, couple, law of movement, Varinus theorem of movement, etc. Today, in video number 7, we are going to solve the problems on non-concurrent force system. First problem, a square ABCD of 2 meter side is subjected to a force of 10 kN, 20 kN and 30 kN along sides AB, CB and BD. Find the magnitude, direction and position of the resultant with respect to A. Now, we will draw the figure as per the requirement from the given data as follows. Now, a force of 10 kN will act from point along AB from point A to B. The force of 20 kN will act from point C to B and force of 30 kN will act from point B to D. Now, as 10 kN and 20 kN both the forces are either exactly horizontal or vertical forces, therefore there is no need to resolve these forces. But the force of 30 kN is inclined force, therefore we have to resolve it in two components. Before that, we have to find the angle between 30 kN force and horizontal force. As this figure is square in size, therefore angle of 30 kN force with respect to horizontal is 45 degree. Now we have to resolve this 30 kN force along two mutually perpendicular components at point B. Since at point B the nature of the force is pull, that is away from the point, therefore components also away from the point. Now resolving the forces horizontally, we get summation Fx is equal to minus 11.21 kN and summation Fy is equal to, we get 1.21 kN. By considering sign conventions as a horizontal force acting towards right direction is taken as positive and horizontal force acting towards left direction is negative. Vertical force acting in upward direction is taken as positive and vertical force acting in downward direction is taken as negative. Now we have formula for resultant R is equal to under root summation Fx square plus summation Fy square. Therefore, by putting the values of summation Fx and Fy, we get resultant R is equal to 11.28 kN. And we also know that direction R is equal to direction of R is equal to theta is equal to tan inverse of summation Fy upon summation Fx. As in this case summation Fx is a negative, but while calculating theta, take it as a positive. Therefore, we get theta is equal to 6.16 degree with horizontal. Now, next step is the position of resultant with respect to A. Now, we will take moment about point A. We get as the force of 10 kN and 30 cos of 45, both the forces will pass through point A. Therefore, moment of these forces about point A must be 0. Now, 20 kN will rotate in clockwise direction with respect to point A. Therefore, there is positive sign. And distance of this 20 kN force from point A is 2 meter. Now, 30 sine of 45 will rotate in anti-clockwise direction and the distance of 30 sine 45 with respect to point A is also 2 meter. Therefore, from this we get summation of moment about point A is equal to minus 2.426 kN meter. Since negative sign indicates that there is anti-clockwise movement. Now, by applying Varinus theorem of movement, we get summation of moment about point A is equal to moment of the resultant, that is nothing but R into X, where R stands for resultant and x is the perpendicular distance from that perpendicular distance of resultant from point A. We have a value of movement, summation of movement about point A is equal to 2.43 and resultant is equal to 11.28. Therefore, we get x is equal to 0.21 meter with respect to point A. Now, last step is the position of resultant. Now, draw a circle with approximately 0.21 as a radius from and take A as a center. Draw a circle, and to this draw two tangents parallel to this. Draw two tangents and select that tangent which makes anti-clockwise movement. Therefore, here in this problem we have selected R as a resultant, x as the perpendicular distance of that resultant from point A, and we know that theta is equal to 6.16 degree. Now next question, determine the resultant of the system of forces acting on a beam as shown in figure. In this problem 20 kilonewton and 30 kilonewton, both the forces are acting exactly vertically downward direction, but 20 kilonewton force is acting at an angle of 60 degrees with respect to horizontal. Therefore, first of all, we have to resolve this force into two components, that is 20 cos of 60 and 20 sin of 60. Now, taking horizontal direction as the x-axis and vertically upward direction as the y-axis, resolving forces horizontally, summation fx is equal to, we get minus 10 kilonewton, and summation fy is equal to, we get 67.32 kilonewton. Now we have the formula for resultant R is equal to under root summation fx square plus summation fy square. By putting these values in this equation, we get R is equal to 68.06 kilonewton. And we also have formula for direction alpha is equal to tan inverse of summation fy upon summation fx. In this case, both summation fy and fx are negative, but while calculating the direction, take it as a positive. Therefore, alpha is equal to, we get alpha is equal to 81.55 degree. Now, taking movement about point A, since 20 cos of 60 will pass through point A, therefore movement of that force about point A is 0. Now 20 kilonewton will rotate in clockwise direction, therefore movement of this 20 kilonewton force about point A is positive. Therefore, movement of 20 kilonewton force about point A is equal to plus 20 into 1.5, since the perpendicular distance of that 20 kilonewton is 1.5 meter. Now 30 kilonewton also rotate in clockwise direction, and movement of that 30 kilonewton force from point A is 3 meter. Therefore, there is positive sign. And 20 sin of 60 will rotate in also clockwise direction, and distance of that 20 sin 60 about point A is 6 meter. Therefore, there is positive sign. By calculating all these calculations, we get summation of movement about point A is equal to 223.92 kilonewton meter. Since there is positive sign, therefore there is a clockwise movement. Now, in this problem, we have to find x-intercept of the resultant. Therefore, formula for x-intercept of a resultant is that summation of a movement about point A is equal to x into ry. If we have to find the y-intercept of the resultant, then that formula becomes summation of movement ma is equal to x into rx, or summation of fx. Therefore, by putting all the values in this above equation, we get x-intercept of a resultant is equal to 3.326 meter. Please note that while finding x, signs of summation of movement and r need not be considered, but while showing its location in figure, see that x is such that the resultant r produces movement of the same nature. In this problem, clockwise in this case. Now next question, find the resultant of the force system shown in figure acting on the lamina of an equilateral triangular shape. In this figure, 100 kilonewton, 120 kilonewton, both are inclined forces. Therefore, we have to resolve it into two components, two mutually perpendicular components. Now, as this triangle is equilateral triangle, therefore all the internal angles are of 60 degree. Now, resolving forces horizontally, we get summation Fx is equal to minus 93.9 kilonewton. And resolving forces vertically, we get summation Fy is equal to minus 53.40 kilonewton. Now we have a formula for resultant R is equal to under root summation Fx square plus summation Fy square. By putting the values of summation Fx and Fy, we get R is equal to 108 km. And we also have formula for alpha is equal to tan inverse of summation Fy upon summation Fx. Therefore, we get alpha is equal to 29.62. Since in this case summation Fx and summation Fy both are negative, but while calculating the direction alpha, take it as a positive. Now let x be the intercept on x-axis from point A, then taking moment about point A is equal to summation of moment about point A is equal to x into ry. Therefore, we get x is equal to 284.6 mm. Since while calculating moment about point A, next question, find the resultant of the system of coplanar forces acting on the lamina as shown in figure. Each square has a side of 10 mm. Solution: if theta 1, theta 2 and theta 3 are the inclination of forces 2 kN, 5 kN and 1.5 kN with respect to x-axis, then tan of theta 1 is equal to 10 upon 10. Since each square has a side of 10 mm, therefore we get theta 1 is equal to 45. Tan of theta 2 is equal to 30 upon 40. Since base of triangle is 40 and height of triangle is 30 mm, therefore we get theta 2 is equal to 36.87 and tan of theta 3 is equal to 10 upon 22. Since base of triangle is base of triangle is 20 and height of triangle is 10, therefore we get theta 3 is equal to 26.565. Now we will resolve all these forces into two mutually perpendicular components, and while resolving all the forces horizontally, we get summation Fx is equal to 4.072 kilonewton and we get summation Fy is equal to minus 2.257 kilonewton. Since while calculating or while resolving the forces horizontally and vertically, we have taken sign convention as if a horizontal force acting towards right direction is taken as positive, if the horizontal force is acting in towards left direction is taken as negative, if the vertical force is acting towards upward direction is taken as positive, and vertical force acting towards downward direction is taken as negative. Now we have formula for resultant R is equal to under root summation Fx square plus summation Fy square. Therefore, by putting the values of summation Fx and Fy in this equation, we get R is equal to 4.655 kilonewton. And we also have a formula for alpha is equal to tan inverse of summation Fy upon summation Fx. Here summation Fy is negative, but while calculating direction, take it as a positive. Therefore, we get alpha is equal to 29 degree. Now, resolving the forces 2 kN, 5 kN and 1.5 kN into their x and y components at A, B, C respectively, and then finding moment of the forces about point O, we get summation of moment about point O is equal to, since 2 cos 45 will rotate in clockwise direction and perpendicular distance of 2 cos 45 from point O is 30, Therefore moment of that force is equal to plus 2 cos 45 into 30. Since 5 sine of 36.87 will rotate in clockwise direction about point O and perpendicular distance of that force about point O is 50. Therefore moment of that force about point O is equal to plus 5 sine of 36.87 into 50. Now 1.5 sine of 26.56 will also rotate in clockwise direction. Therefore moment of that force is equal to 1.5 sine of 26.56 and perpendicular distance is 10. All other remaining forces will pass through point O. Therefore moment of that forces about that point must be 0. Therefore we get moment of all the forces about point O is equal to 199.13 kN. Now distance d of resultant from point O is given by, according to Varignon's theorem, moment of all the forces about any point is equal to r into x or r into d. Therefore we get d is equal to 42.8 mm. Next question. The system of forces acting on the bell crank is shown in figure. Determine the magnitude, direction and point of application of the result. Here 500 Newton is acting at an angle 60 degree. Therefore we have to resolve it into two components as 500 cos of 60 and 500 sin of 60. Now resolving forces horizontally, we get summation Fx is equal to minus 450 Newton and summation Fy is equal to minus 2633 Newton. Since while calculating summation Fx and Fy, we have taken sign conventions as well. If a horizontal force acting towards right direction is, then it will be considered as positive. If the horizontal force will act towards left direction, then it will be considered as negative. Vertical force acting in upward direction is taken as a positive and vertical force acting in downward direction is taken as a negative. We also have formula for resultant R is equal to under root summation Fx square plus summation Fy square. Therefore by putting the values of summation Fx and Fy in this equation, we get R is equal to 2671.2 Newton. And we also have formula for direction alpha is equal to tan inverse of summation Fy upon summation Fx. Here both summation Fx and Fy both are negative, but while calculating direction alpha, take it as a positive. Therefore we get alpha is equal to 80.30 degree. Now by taking moment of all the forces about point O, we get summation of a moment about point O is equal to, as 500 cos of 60 will pass through point O, therefore moment of that force about that point O is equal to 0. Now 500 sine of 60 will rotate in anti-clockwise direction at point O, therefore moment of that force about that point is equal to minus 500 sine of 60 into perpendicular distance is 300. Also 1000 Newton will also rotate in anti-clockwise direction and distance of that perpendicular distance of 1000 Newton force from point O is 150. Therefore moment of 1000 Newton force about point O is equal to minus 1000 into 150. Now 1200 Newton will rotate in clockwise direction about point O and perpendicular distance is the 150 cos of 60. Therefore moment of that 1200 Newton force about point O is equal to plus 1200 into 150 cos of 60. And 700 Newton will rotate in anti-clockwise direction about point O and perpendicular distance is the 300 sine of 60. Therefore moment of that 700 Newton force about point O is minus 700 into 300 sine of 60. Now let the point of application of the resultant be at a distance x from O along the horizontal arm. Then we have formula x is equal to summation of moment about point O into ry or summation of fy. Therefore, we get x is equal to 141.2 mm. Please note that this video is prepared for academic use only to solve the problems on non-concurrent force system for UG students. Thank you. Thanks a lot. For any query, please feel free to contact me on mail or on mobile. Thank you.